towards the business problem. Do I have the right data or not? We have to cross check all the time before we proceed with data preparation and cleaning process. So as we have already discussed, but again I'm going to repeat it, what are the different data types that we find in this world of technology? All applications produces three types of data. Structured data, which comes from your relational databases, which means Oracle databases, NSQL databases, any SQL databases, ERP systems, CRM systems, SAP, Salesforce, spreadsheets, CSV files. That comes under structured. Why? Because why it is called structured? Because it comes in the flavor of rows and columns. Comparatively very much clean. Then there is another type of data which is semi-structured data, XML, JSON. So which comes from your web documents, websites. Okay. So and there is another type of unstructured data that falls under, every data category falls under this. It can be a PDF file, email, everything, books, videos, analog, social media, scan reports of your healthcare, images, audio, video, web page, everything comes under this. Okay, as we have already discussed the data science workflow, but again I'm going to repeat it in a nutshell. So if you think this is your application, it can be your web application or mobile application. From this, your data will be collected to a database, from where I will be pulled into my R system or Python system. Once data has been pulled in, then it has to be cleaned. How it has to be cleaned? According to my business problem, it has to be cleaned. So first, my business problem. Think of, so a bank has approached you, Bank of Maharashtra. Bank of Maharashtra approached you to solve their business problem. They want to give a credit card to their customers. So they wanted to make a decision. Should I give them a loan or not? How I can do it? Then I have to see what data that they have, and we will ask for data. So I got a data. Now what? I have to pull the data as per the inputs given from the business expert who knows the business problem, or might be the business owner. So once we have the business problem, what we'll be doing, it's like we need to study what data that they have given, what inputs that they have given. So based on the inputs, did you collected the right data? You have to go and collect the data from the database. A database can be a SQL database, or it can be in any format. He didn't mention about the format. What if he mentioned about the format which is said like it is in structured format? It can be pulled from any SQL databases. Now think of here MySQL Workbench or MS SQL Server. I pull the data. Then what? I have to clean the data. What kind of cleaning? Look at the columns and values which are really important to your business according to the inputs given by the business expert. Okay, imagine that you have selected, then now it's good to go. What exactly happens? The real intelligence generation will start. How? Data exploration. What I'll be looking at? I'll be looking at all the variables at univariate level, which means single variable analysis with its value, and also missing values and out of range values that can be cleaned, and finding the columns importance, and also finding the relationship between two independent columns. So we'll be analyzing each and every piece of, and also if required, feature engineering, selecting the subset of features or reducing the features by looking at their rows or transactional values, and also feature construction, creating new columns. That will be done through feature engineering. Once you decided, okay, let's say out of 20 columns, 20 independent columns, so I've decided like only 8 columns are really contributing well to my business column. Once I figure out that like this is the column where I can pull my data and apply it on my business problem so that I can make the business generation. So that can be applied through a model concept. What is a model here? Don't think model is nothing but an algorithm. Model is nothing but whatever the selection of columns that you have done through exploratory data analysis. Now you will be passing that as a formula. How? So it's not like mathematical formula or something. So for example, you wanted to do a credit card permission. So should I give them or not? So credit card permission, yes or no, outcome variable. What I'll be writing, I will call my algorithm with respect to my business problem. So since it is a classification problem, I'll be calling my algorithm. What kind of algorithm? Any machine learning, supervised machine learning algorithm meant for classification. I can do logistic regression or decision trees, random forest, naive-Bayes classifier, KNN imputation if required, and also XGBoost, AdaBoost, all that algorithms can be called. So you can pick with one algorithm. Let's say like you started with the logistic regression. So within logistic regression, I call the function. Within that, I pass my target variable. Here, credit card permission. Credit card permission equal to my formula. Credit card permission equal to the columns which I have selected as the most important to my business problem. Let's say like age, gender, marital status, salary, and number of dependents, and number of credit cards, already existing credit cards, and also think of other transactions like debit card transactions, credit card transactions, the number of times he or she made the payments late, delay payments were there, and also other columns like think of home loans or personal loans if there is any. So if you can list out that, and also how many times, how much money you spend online every month from your salary. So once if I calculate all that, then I can, so this is what my formula is all about. Then I can pass, other than that, I can pass my data set, data equal to my training data set, comma, and the next parameter, if there is anything, logistic regression. So which family it belongs to, binomial family. So I'll pass the information like that. Now I call this as my model. I'll show you that. Okay, I'll show you that. No worries. So once I hold the model in, then what is the next step is running the algorithm. So running the model. So it looks at the data and finds out how important each and every value and calculate their variance as your accuracy. Once you see the final outcome, then you will figure it out like, okay, how much correct I am, what is my accuracy. Let's say like I got 80% of accuracy. What is next? Then it's time for testing it. So I should test it with my test data as well. Onto my test data also, I got 77% of accuracy. That's good to go. Now it's time for generating the reports and time to deploy it. So once you deploy it on testing server, then on testing server also you got good results, then it's good to go with a live application. Deploy it with a live application. Sometimes you will be doing two kinds of things. You want to generate the knowledge and publish it on your live application like Amazon or YouTube, or since our business problem is credit card permission, you don't have to publish it online. You can directly deploy it on your database on other real-time data. And if you get the same accuracy somewhere around 72 or 75 something, then your model is really great. Why? Because it's not killing much of the performance of your model. That can also be optimized. You can bring it to 85% or 90% max, not more than that. If something goes beyond that, then it is called overfitted. So methodologies, we have CRISP-DM, which we follow.